your RAM, basically the RAM is a two partitions, obviously compulsory, okay? Because whenever power on, so the system boot up time, power on time, how it works? Tell me. The processor first load the ROM code, ROM, that is a BIOS code on the BIOS. First BIOS program running. First program BIOS, huh?
Yes, sir.
BIOS program first.
Yes.
The BIOS program responsibility to load the kernel image, kernel, your Windows operation, Windows kernel, Linux or Linux kernel. Kernel operating system load the RAM only. First program running the RAM is a kernel. The kernel is the operating system kernel. In the RAM, first, where DRAM, whatever. First program, kernel running. So kernel compulsory. So in the RAM, one partition is a kernel, one partition for kernel. 4 GB RAM is there. Out of 4 GB, equally divided also. 2 GB for kernel, 2 GB for user space, user mode application. 50-50%. Or maybe you can configure the kernel also. Okay, kernel is a 1/4, remaining is a user also. The choice yours actually, whatever you can adjustable. Okay, generally 50%. Okay, kernel and the remaining is a user mode only. The user. So in the user mode, user can run some program actually, some kind of program user can execute also. So user how many number of program run? The depending on the availability of the RAM. Availability of the RAM. The RAM is full, user can stack up. Okay, so there is a different concept. Okay, RAM is full. So now the memory divided to partitions actually. You can see partitions now. So memory partitions. Okay. So first partition kernel, second partition is a user mode programming also. But here two type of concepts are there. Okay, uniprogramming, multi-programming concept. Uniprogramming, multi-programming concept. So uniprogramming indicate only one program run only. Uniprogramming is only one programming. It's the old method. Nowadays nobody use it. So what is multi-programming? Program 1, program 2, like that. A number of programs you can run in the user space. A number of programs you can run. Kernel is one common program. Kernel is only one program. Only one program kernel. Kernel there is no multi-programming. Kernel is only one. It's only one image, one program actually. But user mode, you can run a number of applications like a Firefox, like a camera application, like a multiple programs you can run. Multi-programming concept. So uniprogramming concept, your user mode is a equal side. One partition sufficient on here. There only one partition because one program only. Okay, one area sufficient. But here multiple programs are running only. Every program have different sizes now. Program 1 allocate some size, program 2 allocate some size, program 3 allocate some size, like that. So there is a partition now. Here your more number of partitions required. So now a number of depending on availability. Okay, you want division on a division. Okay, program 1 size 100 kilobytes, program 2 size 200 kilobytes. Overall memory availability, okay, 1 GB. So now out of 1 GB, so program size 100 kilobyte allocating, program to 200 kilobyte. Other program running some available. Okay, other program size different, 300 kilobyte or 150 kilobyte, whatever. But you want allocate the partitions. Create the partition, but unequal size, unequal, not equal, unequal sizes actually now we create. So the partition creating. But partition creating lot of some drawbacks are there. You can see the partition. So what is disadvantage you can observe now. See now. So then what happened whenever the multi-programming concept started? So in the memory management responsibility to find out the memory and allocating. So and here the memory management internally. So this concept actually, okay, the partition divided into two ways they are introducing actually. One is the equal partition. The one concept introducing actually, unequal partition. The two concepts they are introducing. Equal partition concept nothing but whatever the area equally partition, equally. For example, you one concept now. Every area equal size also, equal sizes, equal. Each size is a 8 kilobyte. My assumption just equally partition, This one. What unequal? Whatever memory is available. Unequal partition, okay. The meaning of unequal, one is a 8 kilobyte, other one is a 14 kilobyte, other one is a 4 kilobyte, Other one is a 12 kilobyte. Next one is a 10 kilobyte. Next one is a 18 kilobyte. Like that. The unequal partitions. Two concepts are there only. Because there two concepts are introducing initially, but here some problems are there here actually. What a problem here? For example, the user to run the program. The program one size is a 6 kilobyte only. Program one size is 6 kilobyte only. So in an equal partition, so anywhere you can occupy because all are the free right now. All partitions are equally created, everything is free right now. Anywhere you can occupy now. Okay, for example, here occupy now, P1 now. But 6 kilo, P1 actually 6 kilo. But the partition size what? 8 kilo. What happened here? The 2 kilo is a wastage now. Wastage now. 2 kilo wastage now. This is called a hole. Okay, the hole create the memory hole actually. Wastage now. 2 kilo. For example, P2 process 10 kilo is there on P2 10 kilo. P2 is a 10 kilo, but all are 8 kilo is there. Then obviously we need a two partitions compulsory now. P2 program 10 kilo size. Program size not our hand. The programmer, whatever that depending on your logic, the size coming on. Obviously, okay. So how much you lose now? 16 kilo, nothing but
6
kilo. 6 kilo wastage now. So like that here, anyway you can wastage more here actually, because every program size 8 kilo is a we can't tell about a program or like a program size always 8 kilo maintain. So that is not a correct way, no. So not possible. Okay, definitely here wastage coming on. So that's why equal partition not recommended actually. Second one, unequal enter. Okay, so in unequal, okay, P1 size 6 kilo. So where the 6 kilo can put it now? Okay, here better can put it now. 6 kilo here also possible, here also possible, here also possible, but 8 kilo is a very less. Okay, 6 kilo can put it here. P1 can know. How much wastage here?
2K.
2K. Next to P2 enter also. P2 10 kilo. Where the 10 kilo? Okay, exactly 10 kilo. Yeah, no wastage. Okay, fine, very good. Yeah, P3. P3 enter is a, for example, something. Okay, 10 kilo. 10 kilo definitely you can go to the year one now. Here 2 kilo wastage now. Next P4 enter 3 kilo. Yeah, P4 also enter now. Here. Next to P5 enter 5 kilo. What happened? Tell me. P5 5 kilo. You are only two available. 14 kilo, 8 kilo. But P5 is a 5 kilo. There is no chance actually. Compulsory here occupy. P5 5 kilo. How much waste here?
9K.
9K. So like that, here also a lot of wastage will be there actually. So, okay, unequal partitions also. So the traditional method, memory partition to equal or unequal, because every program is a different sizes only, but both they are tried actually. Finally clarified the two are performance point of view not good only. Finally, the concept introducing in the market, ultimate one, there is a paging concept actually. The paging concept. Now paging concept provide a solution to this problem. Solution. Paging concept also some amount of memory wastage will be there, but that is a negligible, very small amount of wastage only. But they are always better than these two solutions actually. Paging concept works exactly same as a equal partition. The method works on this concept only. But here, see some how to unwastage you can see. Okay, so but the concept is the equal partition. Equal partition concept way paging concept works on. That we are going to see. Okay, how it works on now.